All right, let's go ahead and introduce programming. To begin, let's go ahead and start with computer system parts. After that, we'll talk about a computer's language. And then from there, getting to C++, how we got to today's language, and how we go about typically solving a problem in programming, and the different methodologies that are in programming. To begin with computer system parts, there are two main parts in a computer system, and they are hardware and software. With hardware, you have your CPU, and typically the CPU is the most expensive part of a computer system. The CPU does the calculations, is the brain of the particular computer. All your arithmetic and logic operations are carried out through your CPU. So this is your CPU here. All right. We'll say this is RAM. We'll say this is your secondary storage, input device, output device. So here's your CPU. The next thing we're going to talk about is your main memory, or RAM, random access memory. This is connected directly to the CPU. All right. Anything you input, like if you wanted to add up 1 plus 1, you enter it into RAM first, and then it goes to your CPU, and then once it's calculated, that calculation is pushed back to RAM and then out to your output device like a monitor. If you need to save it later, it goes to your secondary storage like a hard drive. Okay, some of the input output devices, obviously for your input device you have your keyboards, your mouse, your output device, your monitor, a printer. It's important to note that in memory you have memory cells. All right, and each of these cells, say, has a location, okay, in which data instructions, etc., can be stored. Now, all software is written by programming languages. Right? There's two main types of software. The first is system programs, and the second is application programs. With system programs, you have things like your OS, your operating system, and your utility programs. Right? Many of you perhaps have Windows. All right, that's what I recommend using is Windows 10, and then installing Visual Studio on top of that to have and to work on C++. You also have your utility programs such as, disk defrag, etc., that help the operating system perhaps work better. Other utility programs could be antivirus programs are considered utility programs as well. Application programs basically enable us to enhance what we're doing. It allows us to leverage a particular task in some way, such as instead of writing out, you know, um, your paper back in the old days, you have word processing software to do that for you. Those are your application programs. A computer's language. A computer only understands basically electrical charges or no charges, uh, which is a representation of machine language. These charges, no charges are represented by, let's say, zeros and ones, where zero is no charge and one is a charge, or zero is a light charge while one is a heavier charge, so to say. And it's these combinations of ones and zeros that our computer understands, otherwise, again, referred to as machine language. Each of these ones and zeros is considered a bit. All right, those these sequences of bit make up binary code. The pattern of these ones and zeros can be incorporated into an encoding scheme, meaning that a specific pattern could be A, the capital letter A, while another is lowercase a. And another could be return or space or plus or minus. Two of the encoding schemes that we'll talk about here are ASCII, which is very common in the States. Okay, ASCII is a 7-bit encoding scheme. And then you have Unicode, which is more universal. It's a 16-bit encoding scheme, and unlike ASCII, which can include many of the characters that we're familiar with, Unicode represents a variety of characters that can be used other than English. Getting to C++. So as we talked about before, machine language, the ones and zeros, that's what our computer understands. But actually trying to programming it in these ones and zeros can be quite the daunting task. So therefore, it evolved, and as it evolved, we came next to assembly language, which is a mnemonic. Mnemonics are basically instructions that are easy to remember, such as add, okay, add wage, or subtract wage. All right. When we use these types of mnemonics, however, we still need what's known as an assembler to actually translate it back into these ones and zeros that our computer understands. So over time, we've created what are known as high-level languages, from basic, COBOL, C, C++, which we're using in this class, and Java. And these high-level languages, which basically are more like English-like languages or natural languages, all right, that we are more accustomed to, they need what is known as a compiler to translate that into those ones and zeros, the machine language that a particular computer needs to understand. Problem solving. Programming is a process of problem solving. One common problem solving technique includes analyzing a problem and then outlining the problem requirements and designing steps called an algorithm to solve the problem. In a programming environment, the problem-solving process requires the following 3 steps: analyzing and outlining the problem and its solutions requirements, and then designing the algorithm to solve the problem. 2, implementing the algorithm in a programming language such as C++ and verifying that the algorithm works. And then 3, maintain the program by using and modifying it if the problem domain changes. For instance, let's say we needed to find the algorithm for how much you should study for this class. So in order to find the algorithm for how much you should study for this class, the very first thing that we need to do is perhaps get the credit hours for this class. Okay. Once we get the credit hours for this class, then we can find the required study time by taking the credit hours times the required the general consensus of the required study time per credit hour, which is 2, to find the study time. So if you're taking 3 credit hours, you should typically study 2 hours for every credit hour. So the total study time is 6 hours per week, including the time that you should be in class. So 6 plus 3 is 9 total. Okay, so therefore your study time in this case is 6. And that is your algorithm. All right, so from there you implement it in C++. In our class we use Visual Studio C++, and then execute it, and then if we need to, maintain the program. Perhaps we want to add in total study time rather than just study time for our particular class. Programming methodologies. The very first is what's known as structured programming. In structured programming, we divide a problem into smaller sub-problems. Okay, that's what's known as structured design. Each subproblem is then analyzed, and a solution is obtained to solve the subproblem. The solutions to all the subproblems are then combined to solve the overall problem. A lot of times this is called the top-down or even sometimes the bottom-up design process. In object-oriented programming, in which C++ is an example of, the object-oriented design, ODD, is the first step in the problem-solving process, which is to identify the components called the objects which form the basis of the solution and determine how these objects interact with one another. After identifying the objects, the next step is to specify for each object the relevant data and the possible operations to be performed on that data. An object combines the data and operations on the data into one single unit. In object-oriented design, the final program is a collection of interacting objects. And of course, a programming language that implements object-oriented design is called object-oriented programming. So to recap, we first started our discussion on computer system parts, from its essential hardware to the software that runs on top of the hardware that allows the hardware to interact with its different components, such as from the keyboard to RAM to your processor to back to RAM and then out to your monitor. Then we talked about a computer's language, the fact that it only understands the zeros and ones um, that we enter into the computer. We enter in, however, not the zeros and ones per se, but through higher level languages that we use a compiler that turns it into machine language, those ones and zeros that the computer then understands. We then talked about problem solving and how we use algorithms, okay, to help us get to our code. We use the algorithm to provide an outline and basis for us to code, which can then be executed to our satisfaction. And in our case, we use the example of how often and how much you should be studying for our class. And then we talked about programming methodologies, basically structured programming versus object-oriented programming, and how C++ is an example of object-oriented programming.